Okay, we're going to talk today. We were talking earlier about how representations of a certain graph are not unique. And in fact, the sort of structure of a graph is not unique necessarily either. It could just be that the two graphs are the same up to some relabeling and like a redrawing. And this is sort of the question we want to address now. And so the question here could be, are these two representations of equivalent graphs? Are they essentially the same? Could I draw them the same, right? And this is a problem. This is an isomorphism, graph isomorphism problem. So equivalent, the word we use in math is isomorphism. Or we would say the two graphs are isomorphic. And so we're going to define that here, and then we're going to do an example. This problem, though, is a big problem in computational complexity theory, too. This is an MP problem, and it's still unknown if it's MP complete. So, you know, if you could figure that out, you could make quite a lot of money, I think. But let's define this idea of isomorphism, and then we'll do an example. An isomorphism between two graphs is a bijection between the set of vertices. So if G1 is equal to V1, E1, and there's another graph, G2, that has another vertex set and another edge set, then the isomorphism that we're defining, we'll call it F, like your text, is a map from V1 to V2. And we need to show that it's a bijection. First, that tells us that there's the same number of vertices in each set. And then it has an extra step, which is such that if AB is an edge in G1, then F of A, F of B is an edge in G2. Okay, so let's see how this definition works.